Hey everyone, so I thought I would do a quick demonstration of the new MeshFusion Embossing, which is a great feature of Modo 14.0. So let's get right into it. I have this mesh item here, which is just a Catmull Clark mesh item, and it actually has some edge weighting on it. So I'm going to make this my Fusion primary. So I'm going to come over to New Fusion in the Fusion side tab, and I'll click on that, and I'll just call this Fuse Test 0001, and click New Fusion with selected meshes. So now you can see that our Fusion item, which I'll just drag up into this group right here, it's not retaining the edge weighting, which we have on our primary input mesh. So in the Fusion item, I'm just going to enable edge weighting, and it's all the way at the bottom here. So if you scroll to the bottom, click on edge weights, and then I'm going to change the weight loop type to single loop. I just always try to go with single loop if I can get away with it. Now you might notice that the actual Fusion item is still a little bit less, there's like a softer creasing or a softer edge than the primary, and there's a reason for this. So let me just demonstrate why this behaves this way. So I'll click N for a new mesh item, and I'll just drag this to the top here, and I'll come up to the Create side tab. Also, this is kind of interesting. I just recently learned this. If you hold Control and click on these side tabs, you can have multiple side tabs open at once. So now I have Create, Duplicate, Polygon, and Fusion all open, and you can scroll in one giant kind of palette, which has all of these side tabs open at once, and then you can control click to turn off the ones that you don't want to see. Okay, so let me just hold Control and click on this cube, and then I'll just drag this up here, and I'll press Shift Tab to go into Catmull Clark mode. Now I just want to do a quick demonstration of weighting with Catmull Clark, and I want to show how it relates to weighting with MeshFusion. So I'll just press 2 to go into edge mode, middle mouse button, lasso, select all of these edges, and then I'll press Shift W to bring up the edge weight tool. And if you don't see the tool properties, you might have to press K to bring up the properties, and then just click this little circle to pin it. Okay, so with this selected, I'll just click and drag, and you can see that when I get to 20%, I get maximum creasing or maximum hardness on this Catmull Clark surface. And the reason for that, if I go over to the surface side tab on the item properties, and by the way, these item properties, if you also control click on these, you can do the same thing I did over here in the tool properties, where you can kind of scroll through one long list. It's just interesting. I never knew that. I'm not sure if that's new or not. Okay, so anyway, in this surface side tab, we have a subdivision level of 2, and at a subdivision level of 2, a weight of 20% is maximum creasing. So if I increase the subdivision level from 2 to 4, you can see we just got a softer cube, and in order to reach that level of hardness, we'd have to select some edges, Shift W for the edge tool, and then click and drag all the way up to 40. So a weight of 40 will give us maximum creasing at a subdivision level of 4. So there's a direct correlation between the subdivision level and the weighting, and it's 10% for every level of subdivision to achieve like a maximum crease. Okay, so let me just delete this item because with MeshFusion, MeshFusion kind of interprets the weighting a little bit differently. So if I come over to my primary mesh, and if I select these edges here, and I can also press O to bring up my 3D viewport properties, in the active meshes section I can show weight values, and if I select these, I might have to check my vertex map here. Okay, with that selected, with the vertex map selected, I can see the weight values. We're at 0.2, which is 20%. MeshFusion doesn't work the same as a subdivision level of 2 needing 20%. I know this sounds a little bit confusing. You really don't even need to know this, but if I come over to the surface here, you can see subdivision level of 2, Shift W to bring up my weight tool, bring that to 20, click, and it's just not completely hardened. And that's just because when you use edge weighting with MeshFusion, it works on a 0 to 100%. So it's actually a little bit more intuitive. If I click and drag, you can see now, the closer I get to 100, the more harder or the more creased we're getting. So 60% is pretty close to being creased. Now in this case, that's not the look I'm after, but I just thought that's important to know. That's how MeshFusion interprets edge weighting. So actually I'm going to go back to 20%, and I'll turn off show weight values, and I'll deselect my subdivision vertex map, and I'll get rid of the weight tool. So I just thought that was something that's worth knowing. Okay, let's get to embossing. So back to the Fusion side tab, I'll select this item here, and this is just another mesh item. I'm going to select this in items mode, shift select my primary, which is the green wireframe, and then I'm going to come over here to two-sided subtract grid. If I click on that, and then I hide my trim item, and I'll also hide my primary, you can see we have a very thin kind of line where those two mesh items overlap. So if I select my trim item here, I'll temporarily make it visible, and I'll come over to the properties. I have surface strip absolute width, and right now it's set to 1 millimeter, and that 1 millimeter is the size of this strip here. So if I increase that to something like, let's do 12 millimeters, I get a much wider strip. Now I'm also going to come over to my Fusion item, and I have edge weights turned on. I'm going to change my mesh mode from draft to airtight final item parts. And let's also scroll up, and I'll make sure deferred update is on, and I'm going to enable embossing. I have to do this in two places to get embossing to work. You have to do it on the Fusion level, the Fusion item level, which I'm doing right now, but you also have to do it on the source level. So you have to enable embossing in two different places, which might trip some people up, but there's a reason it works this way. Okay, so back to the Fusion source item. I'm just going to come back to surface absolute width. That 12 millimeters is looking good. Let me just change the strip rows. Right now we have 6. And what that means is there's 3 rows on each side. So let me actually change this to 1 so that we have 1 row on each side. So a row of 6 will give us 6 on each side, which will mean 12. A row of 1 will just give us 1 on each side. So we just don't need that many, so I'll keep it to 1. It just makes things less dense. Okay, so now I can come down here and I can enable embossing. So if I do that, you can see we get a few extra strips on each side. So that's just clicking enable embossing. That needs to be on, and that's the second area. So like I said, it has to be on the Fusion item, enable embossing, and it has to be on each surface item that you want to have embossed. So now I can start adjusting the actual middle, inward, and outward offsets. So if I do the middle, let's try negative 15 millimeters. You'll see I just kind of created a channel. And the channel is everywhere this source mesh is overlapping. So if I want to adjust the inward to negative 15 millimeters, now we have kind of like a nice notch cut out. So that's pretty cool. You can also do positive 15, so actually let's do 25 millimeters. And here you can see it goes in or down, and then it goes up. So let's actually move this to 25 millimeters also, so that we go completely up. And that is using the emboss feature with geometry. So we're not using curves yet. This is just another piece of geometry with edge weighting, and everything works as you would expect it to work. Now also this works with mesh operations, which is pretty cool. So I'll open up my mesh operation stack, and I'll click add operator, and I'll just do radial array, double click on this. So that, by default, the radial array, if I open up the tool pipe and click on the helix generator, it has a count of 24. That is just too many. It breaks MeshFusion. So let's just put that down to 4. Click Enter. And now you can see we have 4 pieces of geometry all embossing our original disk. So let me switch over to a camera, and we'll just quickly fire off a preview render of this, and that's the effect we're getting. So we have MeshFusion embossing, we have MeshFusion edge weighting, and we have a mesh operation happening right now. So let me just get rid of this example, go back to perspective view, and I'll remove this item, this subtractive trim, from the Fusion. So I'll just click this button here in the Fusion side tab, this little red minus, to remove this mesh item. And I'll just hide that and deselect it. So now let's talk about curves. We'll do B-spline curves first, and we'll just use the same Fusion primary here. So I'll hide the primary for now, and I'll click on this trim B-spline, and these two trim B-splines. So if I hold Alt and click on the eyeball icon just to isolate those two alone, you can see this is just the letter B. And if I select it, it automatically turns on the curve, the B-spline curve tool. If you don't want the auto activate to occur, you can come up to System, Preferences, and then in Tool Setting, you can just disable Curve Tool Auto Activation. Sometimes that can be a little bit annoying when it auto activates. With auto activate off, in order to get the little points for the handles, you have to come over to Curve and manually turn on B-spline. Okay. Okay, so now that we know what we're working with, let's turn on the primary. So I'll hold Alt and click on the eyeball icon again. And I'll add these to the primary one at a time. I have my curve, my B-spline curve selected in Items mode, and then I'm going to shift-click on the primary. And I'll come over to the Fusion side tab, and again I'm going to click Two-Sided Subtract Grid. When you're using the Emboss feature, right now it only works with this Two-Sided Subtract Grid. You have to use that, as far as I know. So I'll click on that, and now you can see we have the same kind of situation where we have a strip wherever the curve is. Now I should have mentioned this, but this curve is actually conforming to the underlying surface. So let me just do the same thing for the inner B-spline, which is these curves right here. So with these two curves selected in Items mode, I'll shift select the primary, and again I'll click on this two-sided subtract grid. And now we have a strip where those curves kind of overlap the primary, or where they rest on top of the primary. So with these two mesh items selected, I'm just going to come over here to Surface Strip Absolute Width, and I'll change this to 8 millimeters, just so we have a nice thick strip to work with. And I'll also decrease the surface strip rows from 6 to 1, just so we don't have too much density. And that's looking pretty good so far. Also, before I move on, this is a pretty cool feature. Before I turn on embossing, I'll come over to the Fusion item, and embossing is already enabled, but if I scroll all the way down, we have strip polys only. If I click on that, you can see we actually get just the strips. So if I turn off the primary and turn off the curves, we have this. And what's neat about this is with the Fusion item selected, if I just temporarily dupe and convert mesh, and then I just give this duplicate a name, I'll just call it B, and create the mesh. Let me just isolate this by holding Alt and clicking on the eyeball. So we're just looking at this mesh item. The output is always all quads. So you won't find a single triangle here. And this is true for any strip. Strips in MeshFusion are always all quads, which is really cool. Like right here, it looks like it might be a triangle here, but it's in fact a quad. So I just thought that was worth mentioning. So let me delete this Fusion output mesh, and I'll turn on my Fusion item, click on the Fusion item to bring up the properties. I'll close this output window, and I'll turn off strip polys only. But that is a really cool feature. Okay, so back to my B-splines. I'll select this B-spline first, and in the mesh item properties, I'll scroll down, and I want to make sure the extrude direction is not extrude perpendicular to curve. Because this curve is actually resting perfectly on top of the underlying surface, I used mesh constraints to kind of make it conform to this this geometry. I'm going to actually switch the extrude direction from extrude perpendicular to curve to extrude along surface normal. And that changed the surface slightly. But that just gives us more accurate results when dealing with a curve that is constrained to the surface. Okay, so again, I'll come over here to enable embossing, and I'll turn that on. And once again, that gives us the extra rows here. So with enable embossing off, there's less density. Enable embossing on, more density. But now what we can do is I can change the middle offset to, let's do 12 millimeters. And there we've got some embossing happening. Let's do the same thing for the inner B, the holes or counter of the B. So I'll select this curve, and I'll enable embossing. And that gives us the extra rows here. So off, on. And then I'll take the middle offset, and what did we have? What did we say, 15 millimeters? Is that what that is? No, I guess not. That was 12 millimeters. Let's make them both 15. So with both of those selected, I just changed it to 15 millimeters. And that's the effect we're getting. So there is some embossing. We can easily do negative 15 if we wanted to, negative 15 millimeters. And it will just go inward like a channel or a trough. Let's put that back to 15. And now let's actually make this rise up in the middle. So I'll select this first, the large outline of the B, and let's try the inward offset first. So I'll make that 15 millimeters. And that didn't do what I thought it was going to do. It actually made the outer part raise up. So let me put that back to 0. And let's do the outward offset. We'll make that 15 millimeters. Okay, so that did what I expected. So if I turn off the wireframe and select the Fusion item, you can see now we have a nice clean ledge for the outer B. But the inner B still has this trough. So let me select that. And let's make the inward offset of that 15 millimeters. Nope, that didn't do it, so let me hit 0 to undo that. And the outward offset will make 15 millimeters. There we go. So now, if I select the item, the mesh item, and toggle the wireframe, now we have a nice effect going on there. We could also take both of these items and we can set the middle offset to be something like 20 millimeters, and that'll give us a nice, like the middle part will kind of jut upwards. So let me turn off the wireframe. Let's have a look at that. So that's pretty cool. So that is using B-splines. Let me show you another example of using B-splines. We'll kind of combine the first thing I showed with B-splines. So I'll turn those curves off. I'll enable this new curve, which I have right here. And again, this is another B-spline curve that is constrained to the underlying primary here. So with just this selected, let's control click on the primary, and once again in the Fusion side tab we'll click on subtract grid. And here, even though this is an open curve, it's not closed, it's still working really well. So again, if I select this trim item. I'll scroll down and I'll choose the extrude direction. I'll change that to extrude along surface normal because again this curve is constrained and it appears to have been it's broken, right? So I'm going to enable manual extrusion depth, and then I'm going to change this extrusion depth to 5 millimeters. Just because this depth is how far the curve is away from the surface. So you can see here it's kind of off the surface, but that 5 millimeters allows it to project through. So now I'm going to change the surface strip absolute width to something like 8 millimeters. Let's just have a look at that. It's looking pretty good. Again, I'll bring the surface strip rows down to 0 or 1 actually, like so. And let's enable embossing. So I'll click enable embossing. That gave us the extra strip rows. And let's take the middle offset to -8 millimeters. Okay, so that's working pretty well. It looks like there's an error here, but I think if I go to my camera view and if I look at this in the render, the preview render, I think it's actually fine. So turn on preview render. It's totally fine. Yeah, so that looks fine. So this is really good for making like channels in hard surface objects. Let's go back to a perspective view, and I quickly want to show how we can actually mirror curves because it's not very intuitive actually. So I'm going to select the curve. I'll come over to the curve side tab, enable the B-spline tool, K to bring up the tool properties. I'll pin that. I'll change my mode from edit to add, and then I'm just going to middle click on this curve so that it deletes it. And then in polygons mode, I'll just make sure the curve is selected. 1 to bring up items vertex mode. I'll select this vertex. I just want to make sure this is perfectly this vertex is sitting perfectly on the ZY 0 plane. So I'll come over to geometry, vertex, set position 0 on the X, click OK. Now I'll select this curve. Alt W to bring up or to make sure I'm in origin action center. Shift V to turn on mirror. Click on the viewport to mirror, and straight away it looks like it's working. But right here, I know that even though if I select this vert and it shows up as one vertex, this one vertex is actually being shared by 2 polygons. So if I shift select both of these, you can see it actually is 2 polygons, which is we need to merge these. So I'll come over to the polygon side tab, merge, and that just makes sure that it's one single B-spline curve. So now back in the curve side tab, I'll enable the B-spline tool and I'll just click closed, and that will close that up. And it looks like this is swimming underneath the surface, so I'll change the mode to add, and then I'll click on this point, and then with the mesh constraint on and the geometry constraint type set to vector, I'll just click here, and I have to make sure I have an actual background. Oops. And I have to make sure I'm in add mode. And that broke for a minute, and I think, let me just delete this one more time. I think I accidentally created another curve here, so let me just address that. Whoops. I keep accidentally clicking off the point. Let me just make sure I don't have any other curves here. Yeah, so I have, here's the problem. So let me turn on the B-spline tool. This point right here, we just delete it. Oh, I see what the problem is. So let me go into add mode, middle mouse button, click that. I have to draw it from this side. That's the problem. That is just some classic user error on my part. So go to add mode and click here. Ta-da, that's looking pretty good now. Okay, So now, with this subtractive trim item, I can change from 8mm, let's do 12mm. That's looking pretty good. And again, if I wanted to, I can come over to the inward offset and I can make this negative 8mm also. And that'll just push it in so that now, if I look at it here, it just kind of goes completely in, which is a pretty awesome effect. And again, if I go over to the Mesh Operation tab and add a radial array. This doesn't have to be a radial array, just because my primary item is a circular disk. It makes sense to use a radial array. And this will break once it's done thinking, because it defaults to 24, and that's just too much for MeshFusion to handle. Okay, so we're going to go over to the radial array helix generator, and at first we'll change this to 4, and that corrects things. We can always bump this up to 8. And let's actually look at this in the preview window. So that's pretty cool. If I come back over here to the trim B-spline, I can change the inward offset back to 0, and that'll give us more of a channel as opposed to like a subtractive dent. So there we go. So that's using the B-spline. Now, last but not least, let's move over to using text. Specifically, let's do procedural text. So here I have another primary. It's the same sort of deal, so let's just review this. I'll select this primary. I'll come over to the Fusion side tab and create new Fusion. I'll call this fuse text 001. And again, we have to come over to the Fusion item, and we have to enable deferred updates, enable embossing, and turn the mesh mode from draft to airtight final item parts. That's optional. I just like to do it. And then we'll turn on edge weighting, and we'll set the weight loop type to single. That's also optional. It's just the way I prefer to work. Okay. So here I have a hidden item. It's just procedural text, and it says emboss. And you can see this procedural text is hovering above the primary. It's not actually conforming to the underlying surface as if we had the mesh constraint enabled like we did previously. But if I open up the mesh operations window, you can see that this text is procedural. So it's pretty simple. Even with procedural text, you just select the item, shift select the primary surface, and again click on this grid subtract. And there it appears to be working, which is nice. We can come over to this actually says trim B-spline, but it's actually, if I click on the text, the output type is set to bezier. So I should actually change that, but let's do that real quick. There we go, just to be accurate. Okay, so now in this trim item, I can come over here. Now, I could adjust the absolute width, but with Bezier curves, I tend to leave it at 1 millimeter. It's really up to you. I am going to, let's see, I do want to keep it at extrude perpendicular to curve. I don't want to change it to a long surface normal, just because, like I said, this curve is hovering above the surface. I do need to enable embossing. There we go. That'll give us the extra rows. I am going to enable manual extrusion depth, and when I do that, you'll see something happens here. I click manual extrusion depth, and part of the E is cut off, and part of the S at the end is cut off. And the reason for that is just because of the distance between the curve and the underlying surface. So if I select this and change the extrusion depth from 100 millimeters to 185 millimeters, it should, oh, not 185 meters. So we're going to change that to 185 millimeters. There we go. So now the E actually completely comes back and the S comes back. So now all we have to do is turn on sharp Bezier corners. This is one of the benefits of working with Bezier curves. You can see right here at the corner of the E, it's very rounded. If I turn on sharp Bezier corners, that'll become very sharp. And I can actually increase the surface strip width. Even though I said sometimes I don't like to do it, we'll make this 3 millimeters just to see what happens. Maybe we'll try and make it 5 millimeters or 4 millimeters. I'll bring the surface strip rows down to 1. And now let's change the middle offset. Since this is embossing, it's rising above the surface, let's do 12 millimeters. Okay, so now we can see here on the B, it's almost like we have walls, which is pretty cool because if you use the Bezier curve tool and just start drawing, it's almost like you can make, walls for, for architecture. But I am noticing a problem here with the E. It's like it's only half working. The S is working. I'm thinking this might have to do with extrusion depth, so let's just bring that up to 225 millimeters. Let's just try increasing it. And that did the trick, so now that's working perfectly. Let's bring this up to 25 millimeters. And let's make the inward offset also 25 millimeters. There we go. So that seems to be working pretty well. Let me select my fusion item, turn off wireframe. Let's actually go into Gooch. So Emboss is working really well. We could also select this, and if you want it to be a little bit more stepped, you can take the middle offset and do half of 25 millimeters. You can either do 12.5, or you can use math directly in the text input fields. So if you just divide this by 2, you get 12.5 millimeters. And here you can see it's kind of stepped. Or you can make it higher, 32 millimeters. And now it's going to rise above, and it's going to give us that kind of outline or border, which is pretty cool. And remember, the power of this is that it's actually procedural text. So if I click in the text, let's actually bring up this camera and frame this up and fire off a preview. If I come into the text item here, I could change emboss to Modo exclamation point. And there we go. Okay, so let's try a deboss real quick, just to go through everything that we know so far. I have this item here. It's the same as the emboss. It just says deboss now. This procedural text item. So let's select this. Let's shift select the primary. We'll click here on subtract grid. Okay, so that seems to be working. And now in the fusion source, the subtractive source, we'll just create we'll turn on manual extrusion depth. That's going to make part of it disappear because 100 millimeters isn't enough. We could try 185 at first, and that should work. And if we get problems like we did with the emboss text, we can always just increase it. We want to keep the extrude direction to extrude perpendicular to curve because again, these curves are not conforming to the surface. I'll enable embossing. Enabling embossing will give us the extra geometry on the strips. So there we go. I'll enable sharp Bezier corners because this is a Bezier curve with corners. And that seems to have broken it. That's fine. Let's try increasing this extrusion depth just to see if that is the culprit. Okay, so that was it. That oftentimes is the issue. So let's increase the surface strip absolute width. Let's do something like 6 millimeters, just to make it larger. Surface strip rows, we can just reduce that to 1. We don't need that inner. Honestly, I don't think having the surface strip rows set to anything will affect this with embossing enabled, because embossing kind of overrides that surface strip rows, I think. Okay, so we're going to deboss this. So let's do middle offset. Let's do negative 10 millimeters. That just creates a channel or trough. It's, you know, a subtractive element. And then let's do the inward offset. Let's make that negative 20, just to double that. So negative 20 millimeters. Okay, let's hide this curve. Hide the primary. Go back to our preview. So we have an emboss at the top and a deboss at the bottom. It's pretty cool. And again, it's procedural, so if I open up the procedural stack and click on this text, I can just do, let's do Modo again, because I can't think of anything else to say. There we go. Modo. So that's pretty cool. Okay, let's try one more thing. This is good for more than just text. Let me just bring this Fusion item into this group, like so. And let's open up this final group here. And again, I have a primary shape here, and then I have 2 curves. And these curves are just the Modo logo. Oops. There we go. So I have the outer ring, and then I have the inner ring here. So again, we have to create a new Fusion item. So I'll select this primary, come over to the Fusion side tab, and I'll click New Fusion, and I'll just call this Fuse Logo 0001. And again, in the Fusion item, which I'll drag into that group, let me just make sure that Fusion item is selected. I'll turn on Deferred Update, enable embossing. I might as well turn it on now. I'll scroll down and change the mesh mode from draft to airtight final item parts. I'll turn on edge weighting, and I'll change the weight loop type to single loops. Okay. So now with this outer ring selected, these curves, and again, these are Bezier curves. Since these are just circles, this could be either Bezier or B-spline. It doesn't really matter. It can even be geometry, like I showed in the beginning. So with this selected, I'll shift select the primary. I'll come over to this subtract grid, and I'll click on that. And straight away we're getting these strips, which is cool. So with this subtracted trim selected, I'll just change the surface absolute width to something like 6 millimeters. I'll change the surface strip rows down to 1. Again, I don't think this will matter because we're using embossing. I want to leave this as extrude perpendicular to curve because it's hovering over the surface. And I will use manual extrusion depth, or maybe I won't on this one. Let's just see what happens. I'll enable embossing, and I'll enable sharp Bezier corners. And let's decrease the middle offset. So let's put it down to something like negative 16 millimeters. And let's do the same for the inward offset, although maybe we'll do negative 12 millimeters. So there's a little bit of a step. I'm trying to determine if I should do something different there. No, I'll make that negative 16 millimeters also. So it's just a nice clean kind of channel. Okay, so let's do the inner logo now. So I'll select this curve in items mode, shift select the primary, and then I'll click on the subtract grid. Okay, so that actually broke the fusion. So let's go over to this curve and let's make the surface strip absolute width something like 4 millimeters. We'll change the surface strip rows to 1. And I'm noticing some lag, but we'll just deal with that. We want to keep extrude perpendicular to curve as the extrude direction. we'll enable embossing, and we'll enable sharp bezier corners. Okay, so enabling sharp bezier corners is what helped it along. So sometimes it looks broken and it just needs the right combination of things to work. Okay, so with embossing enabled, let's start tweaking this. Let's have it match the inward offset and middle offset of the rings, the outer circle. So that's negative 16 millimeters. I'll bring this to negative 16 millimeters on the middle. That should create channels like so. And I'll do the same thing for the inner, negative 16 millimeters. Okay, so now if I hide all of my curves, you can see we have a nice Modo badge or a nice Modo coin. There we go. Let's go into Gooch mode. That's a pretty good way to see the embossing effect or the debossing effect. Or we can go to the camera view. So that works pretty well. And I just wanted to show an experiment that I was doing. I was really pushing MeshFusion, using everything that I know about Fusion, just on kind of like I mean, this is ultimately just a sketch, but the point was to try and use everything that MeshFusion has to offer, from compound trims to intersecting fusion sources to the new embossing. Like these eye shapes are totally embossed. And you can also, I didn't show it in this video, but you can round the corners. You can kind of like make them less angular or less harsh. But this is just using everything MeshFusion has to offer to show how robust MeshFusion is. Everything just plays nicely as long as you know how to kind of troubleshoot, and as long as you have the patience to stick with it. So it's just an abstract kind of sketch. But I hope that was useful. Thanks for watching, and stay tuned to Pixel Fondue for more videos.